So what are the other types of video stabilizations available? Now, of course, there has been a whole lot of work of doing optical and in-camera stabilization. Of course, in this kind of stuff, people have attempted to stabilize the lens itself, or basically also adaptively change the sensor as, for example, motion happens on a camera. And for example, here just showing you two different pictures on how we can actually stabilize the optics itself or the sensor to the motion. And these kind of are being embedded into the cameras itself. And again, you see on high-end SLRs and stuff, they have these types of features. Sometimes they can also use the accelerometer and a gyro, which actually is becoming even more and more popular with the newer handheld cameras, where you can use the fact that there is a sensor built into the camera, which tells you how fast the camera is moving, and you can use that as a priori information to remove some of the jitter. But remember, one of the biggest things with all of this is that they're actually there to get rid of the high frequency perturbations. The shake because I'm moving the camera too fast would be the ones that I'd do it right there. So which basically also means that they're looking at a smaller temporal buffer. In the case that we're talking about, we'd like to also consider post-process stabilization. That is, that removes the low frequency perturbation, large buffer. So for example, in the case of the jogger that we saw in the marathon, the head motion was relatively slow. And that's the very kind of low frequency motions, and we'd like to get rid of that. That means we need to keep a bigger buffer. That can only be done as a post-process. That is, after all the video is done, uploaded or saved, we run the process on it afterwards. This can be done actively in the camera itself. Another part of it is that if we do the post-process stabilization, we can actually use a distributed computing backend, which basically means we can actually spend a lot of compute energy. This is what I showed you with the example on YouTube. It goes to a cloud, a whole lot of processing is done, and actually we get much more accurate results afterwards. The biggest advantage of the post-process stabilization, of course, is can be applied to any camera. It doesn't care where the footage came from. And in fact, you can actually apply it to legacy footage. Now, of course, stabilization is something we want to accomplish for the kinds of videos where we want to get rid of some of the errors. Whenever I talk about stabilization, many people come and say to me, oh, in some artistic ways, we actually want to add shake and jitter. I mean, movies like Blair Witch Project and Cloverfield were ideally designed to actually show you all of the kinds of motions and jitters that the director wanted. We don't want to get rid of that kind of stabilization. We're particularly interested in stabilization of videos from casual cameras. So our goal is to now focus on this part of the process here. We're going to talk about post-process stabilization, but the kinds of techniques I'm going to talk about with knowledge of more information from the camera itself can also be applied to in-camera stabilization.